Are you talking?
Yes, we're here and we can hear you.
Okay, I wasn't sure if I came through. Okay, good. Let's go. Yeah. Where is?
So I guess our main concern um, is on that first one. You're not
Yeah.
wanting an actual value as an answer. You're wanting us to set up the integral and the equation for what the probability is, and then explain where the parts of those integrals came from, right?
Correct. That is, you don't have to solve the last step of actually getting a number. If you get to the point of setting up the integral, that's enough for it. Computing the integral is a totally different thing, which we can tackle separately in module 5. So
Right.
let me share my screen here. So if I just gave you the problem statement and then asked you to say, let's say I asked you set up the integral that should be solved to get the probability that there will be m particles in a droplet, I would expect you to come up to here and say this is the integral that needs to be solved, and you can do this through MATLAB or Python, or write your own code or use some numerical technique. But this is it. This integral, if it is set up correctly, it means you understand what it means to calculate this probability, considering the fact that the droplet diameter itself can change over a range of values. It's not a fixed number like 15 microns. That's the understanding I want you to demonstrate.
Okay.
Or so, and you're multiplying the two probabilities in the integral because
Yeah.
they affect each other? Is that how that works?
No, no. If you read this document here, I start with writing what's the probability for m particles per droplet, which is given by Poisson.
Yeah.
And then Poisson has lambda, and lambda depends on the droplet's volume. So lambda scales with the droplet size. So if you make the droplet twice as big, lambda becomes 8 times bigger. That's what I meant by that. So lambda is a function of x. You agree with me?
Yes.
So when you write the probability expression where lambda appears and lambda itself depends on x or the diameter, that means P of m depends on the diameter through lambda. To get P of m for all the droplets, considering all possible values of the diameter, we should consider the probability of x assuming a specific value, which then goes back to what distribution that x follows. And that means you have to think about what's the probability that x will take on a value between, say, x and x plus dx, which is nothing but f of x dx. This is what we saw earlier in the maybe fourth or fifth lecture sometime, that f of x dx is the probability that x takes a value between x and x plus dx. So then you come back here and say, if I want to get the value of P of m, considering all possible values of x, and we call it Pm averaged over the diameter x, that would be what is Pm, which depends on lambda, which depends on x or the volume, and then multiply by what is the chance that x will take on a certain value, and then sum over all possible values of x.
Okay.
Is the train of thought making sense? It's not about multiplying two uh, probability functions without reason. It is to say, I'm interested in the average value of this quantity, but the main parameter x here is not a single number. It itself follows a distribution, which in this case is given as the normal distribution. How do you then account for, or how do you then think of this whole f of x dx as a number that varies between 0 to 1. It's basically the chance or probability of x taking different values. Some values are more likely, some are less likely. So you are taking this function and weighting it by the probability that x will take a certain value, and then summing over all possible values of x. This is literally weighted average, where x follows a distribution instead of being a single value or a uniform range of values.
Okay.
Okay.
Yeah. Hearing that out loud makes that make a lot more sense.
Okay. Okay. I'm glad. Yeah.
Yeah, I think the core of my misunderstanding was you were saying continue to work on it. So I was trying to get a actual value out of
Well,
this.
okay. If let's say our goal is to get an actual value, you can think of what this function is. This is an exponent of this is an exponent of x cubed. This is an exponent of x squared. It's not easy to solve them analytically. There is no like simple way to do this by integration by parts or anything else. You would have to resort to numerical techniques or some kind of approximations. Like you have to approximate the exponent by a polynomial, this exponent by another polynomial, and so on. So you can do that in principle, but that's not the point. If I told you nothing and just asked you to just set up this integral, would you have been able to do that? If you are able to do that, that means you know what to solve, how to solve, we can deal with it separately.
Yeah.
Okay.
Yeah. Just rewording the question makes it a lot easier to manhandle.
See,
And
the thing about these questions is you can't like you won't learn anything if I just tell you this is it, just accept what I say. I need to let you wander a little bit and then come back to the answer, then so that you will find something in your wandering. If I just tell you go there, you go there and you won't see anything else.
right. And then will it be the same concept for like number 4? Because while that integral is not as scary as this one,
Hmm.
you know, like when we were mathing it out last night to get the number we did, I think it was still 4 or 5 parts that we had to break it down into to get that 486 number.
Right, you got 486, right?
I believe that's
For the integral, yeah.
yeah.
For the integral. So you understood the part where the mass of a pebble depends on its diameter, and the probability that a pebble would have a diameter is always f of x dx. In this case, f of x is a different function. It's not your Gaussian distribution. So then you then compute average mass, which is then mass of a individual pebble multiplied by the probability of x. Then you get this integral. If you get up to here, in theory, you have solved the problem or at least set up the problem. And then it's a mechanics of computing the integral. So in the exam, I'll provide you such a formula which says, if your integral looks like this, where n is a positive integer or non-negative integer and a is a positive number, n factorial divided by a raised to the n plus 1 is your integral. So all you have to do is apply your values of n and a that is in your situation and compute that integral and go. Asking you to do integration by parts is not the point.
Gotcha.
So you should be able to get up to here correctly. Suppose you made a mistake and you had instead of x cubed, let's say you had x squared or x something. Even if I give you this formula, then you won't get the right answer because you didn't get to the right question.
Yeah, okay.
I posted these on the canvas. Do you see that or
Yeah,
are you?
We had looked at it because when we had gotten, well, you plugged it into an integral calculator, right?
yeah, I did it with the
think-
step. I did it out with Brian, and then I got that 169 and I didn't believe it, so we went through a calculator and still got 169.
Yeah, listen, we saw 169 and said pebble, and that kind of threw us through a loop for a second. So I think there was a little bit of a sigh of relief when you posted this solution.
Yeah,
Sure.
because
But
it like math wise it passed, you know, numerically, but it just didn't pass the logic pass.
Okay. Okay, maybe this I mean it's not that far-fetched. If you really look at some rock samples, you can find such pebbles. But of course, none of us are geologists, so let's not get into that.
Yeah.
Yeah,
Well,
I agree with that.
you know, when I saw it, it's just like it's a very loose definition of pebble. So it was just us not being confident enough in knowing that we were doing it right, and so therefore questioning our understanding of the question itself, not the math behind it.
Okay. Okay.
Um,
That's fine. Yeah.
and everything else is kind of, or 2, 3, and 5 are
Yeah, those were
kind of
fine.
easy sauce. I do see that on 3 you had like 7 iterations. You said you're going to give us a range, a
I told
predetermined range
you
on those, right?
I told you I'm not going to ask bisection. You're not getting bisection on the test. It will be
Yeah, in
only
the email you said
Newton-Raphson
secant.
and secant.
Yeah, but we still need 2 guesses for secant.
That's correct. You still need to get 2 guesses.
Okay, and will we be making those, or are you going to give us kind of a ballpark?
Either or. If I don't give you anything, you should be able to pick some guesses. Typically, you just look at the function, see if you can find something like you apply 0, let's say 0. I mean, you try to pick something that's reasonable and reasonable in the sense something that's, let's say for the purposes of the exam, something in the range of 0 to 3, maybe -3 to +3. I won't make you guess outlandish things. Most likely I'll provide a guess, but if I don't, -3 to +3 should be a good starting point in general.
Okay.
Okay. Yeah, I was gonna say, because would it be valid to like graph the function to look at where the 0 is and then just kind of go
That
+/-1 from that value?
that
Just
would
to
be
zero in
ideal.
on?
That would
Okay.
be ideal. You graph it even on using pencil and paper, just graph it approximately. I mean, just pick 3 or 4 values, see how the function behaves. And if you see that there could be a root between 1.5 and 4 or 1.5 and 3, whatever, just pick those 2 as the guesses because the method will then take you closer.
Okay.
Let me double check number. Oh, that's his screen. Yeah.
I can stop sharing.
Which one are you trying to check to?
And then number 5, we did that in class. Let me go back to the page I had it on. Because I think I wrote something down wrong, and I just want to clarify.
Okay.
Let me find where I had it. So when we're finding the numbers for the t-chart, we got n-1, n being our sample size.
Mm.
So in this question, it goes from 28 to 27.
Yeah.
But when we're calculating the value for t, the square root of n, are we using the original sample value,
Yes.
or are we using the... Okay,
Original sample size. Original sample size. Yes. That is
gotcha.
when you look up the t tables, you look up for the degrees of freedom, which is 1 less than the sample size. But wherever it appears as square root of n in your t statistic calculation or your confidence interval calculation, that is the number of samples. So 28 samples, 28. When you look up the t table, you look for 27.
Okay, that works. I just wanted to clarify. I had just wrote it down in my notes wrong.
No, you had it right.
I don't think I have any other questions.
Yeah, I think that's our ground covered.
Okay, good. Yeah, I posted some additional recordings from previous years. See if they can help you.
Okay.
It's like I think the most mind-boggling thought was the 2 probabilities in the integral, but I think that makes sense.
Such new ideas, when you first see them, it will look daunting, but the more you handle them, they become familiar, and then you will It'll stop looking mind-boggling. It'll just be a routine thing. Oh yeah, I want the average of this. This depends on one more thing. That thing has a distribution. So in the end, I have to multiply these two and integrate over the range. So it becomes routine.
Okay. Yeah, it makes sense from like an applicable standpoint. I think I'd be able to see it and apply it. But like from just a straight theory standpoint, I'm a little foggy on it, but I don't know if that will just make sense in time or
You think about it like this. If you think, let's say, for example, you just count. Let me give you an example here. Let's say you take a state, and each state is divided into counties, and then there are different number of people in different counties, like the population. If suppose you look at some quantity, like what is the net worth of each individual in a county. So you can calculate different quantities like what's the average age of people in a county, or average height, or average weight, or average wealth, or worth, something. So it's like you have to take a weighted average of each person. The weightage is not that they are, if you're just counting votes, everybody gets one vote. That's democracy. But if you just count the net worth, let's say one person has a net worth of $1 million, somebody else has 10 million, somebody has 100 million. So in terms of that weightage factor, the wealth you have contributes or gives you more weightage or representation in that average than a simple number count would do. So this multiplication of two distributions is you take a single droplet, its lambda parameter scales with its volume. You take a larger volume, more likely you will find more particles, and vice versa. So if it scales with the diameter, then we are saying, oh, by the way, the sprayer also makes droplets of multiple diameters or different diameters. We have to account for that variation. So we multiply the two and then sum over all such possibilities. So it takes some thinking and getting used to, but the more you do this, the idea will click. Some things you understand instantly, some things you understand by doing, and over time it will be like, yeah, of course that makes sense, and it becomes natural.
all right. Good.
Yeah, I think I got it stuck in my head.
Yeah, I think that helps. So I appreciate that.
For the
Okay.
participation grade, can we
Yeah.
send you the picture of the whiteboard that we were working on yesterday as a group, or do you want us to kind of rework what you've shown us there for Mach 1?
Yeah, it's an individual exercise. So even though you study together, if each of you can write it up on a sheet by yourself and upload it, it'll keep it easy to grade. I can't have 4 people turning in the same thing and expect that. I mean, it's not correct. So just turn in your own assignment regardless of how you study.
Okay.
Yeah, fair enough.
Seems reasonable. So.
Yeah, for the participation after the spring break, I hope to give like a amnesty program wherein I'll just open all the exercises and let people submit whatever they missed, so that people who missed it because they didn't understand the submission system or whatever, they don't lose out. So by around maybe March 25th, I'll do this, make a list of all the exercises and give it to you guys. If you missed some earlier score, just get it done.
Fair enough. I think I've gotten everything turned
Yeah,
in.
so
So
I
it
was
doesn't
just
concern me, but good way for people to try and catch their grade up. Well, I appreciate it, Dr. Rango. You have a great rest of your day. See you tomorrow.
Thank you.
Yes. Thank
See
you.
you. Thank you. Bye.